every answer. You should have the ability to draw. In fact, I will always move ahead to also tell you that your answer writing in geography, those of the candidates who are able to write good answers in geography, I have never come across any candidate who has written good answer in geography getting less marks in the entirety of the mains. Because geography answer writing teaches you how to be descriptive and ensure good presentation with the images. So that will allow you to form flow charts, block diagrams, etc. Even in the case of polity, governance, sometimes even in art and culture, economics, more importantly, ethics, essay writing also sometimes. So not so much in essay writing, but in the GS4 and 1 to 4 GS subjects. So I have always seen in my past experience, I can vouch this with a kind of a certainty that always it is the case that if you are writing good answers in geography, I can give you a guarantee, you will score good in all the various answers, because then you would basically know how to explore that answer writing. You will be exploring and pushing the limits. Okay, right? So keep that in mind. Now, Mega, how to link answers with newspaper data? Wait for it. Wait for it, my dear friend. Wait, have patience for around 10 to 15 classes. You will develop that approach on your own. I'm not going anywhere before 24 classes. I hope neither are you. Have patience. Now, we talk about the case of convection current theory. What is this convection current theory? So this was provided in the 1920s, 1919 onwards, by one of the proponents who basically, in his studies, he actually took physics as his area of expertise, but eventually he veered towards the portion of geography. It was that individual who is credited with the development and the detailed development of radiocarbon dating, which helps us find the evidence and the age of the rocks and the fossils as well. So this was provided. Is the continent still drifting? Absolutely yes. India is still moving northwards. Africa is moving northwards. Africa is breaking into two. North America and South America, they are indeed moving westwards. So the continents are moving. Australia is moving in a northeastern direction. So yes, the continents are indeed moving. In the near future, you will find that the Mediterranean Sea will disappear because Africa will collide with Europe, and there, instead of the Mediterranean Sea, you will have mountains just like the Himalayas, maybe taller than them. So the continents are moving. And by near future again, understand, we are talking about maybe 100 million years or 150 million years from now. So this theory was provided by Sir Arthur Holmes. Why I do need to specify the time, I would have told this to many of you. Basically, when in one of the classes, I told the candidates that there's a fourth range of Himalaya coming up in the northern portion of Uttar Pradesh and Bihar in the coming years. One of the students, they wrote a long mail that could you support this, because my father recently bought a piece of land there, and if Himalayan ranges are coming there, that means our money has gone to waste. So just so that you don't panic, it is not going to happen in your lifetime. Maybe we humans, we don't exist till that point of time, but basically that is how the movement happens. Okay, so this was the convection current theory. This was provided by Arthur Holmes, and it works. He basically said that heat from the inside the Earth's surface, that gets transmitted to the surface with the help of convection current. Now, what is a convection current? So basically, you would have seen, ever if you have boiled a pot of water or milk, in case you have not done this in your life till now, high point in your life to do this. if, let's suppose, you try to boil water or milk. Now, what is it that you experience? Is it the case that straight away the bubbles start forming on top of water? No. Initially, if you have noticed carefully, you will find that small bubbles, they start forming at the base. Bubbles basically means water is getting converted into steam, into vapor. Small bubbles, they start getting created at the base because that base is getting heated up. Then these bubbles, they start rising up. They start to rise up. They reach the surface. Meanwhile, the colder water from the sides, they replace this. Portion which has risen up, they replace this. So in a way, heat is transmitted by the motion of water. Heat is transmitted by the motion here, movement of particles. So convection current, when we talk about convection current in its entirety, this is transfer of heat. Heat due to the motion of particles. The hotter particles, they rise up, the colder particles, they settle down, they sink down, and that is where the heat basically gets transmitted. Now, when we talk about this convection current here, basically, what is it that he said? He said that, look, when we talk about the Earth's crust, beneath the Earth crust, you have the mantle, you have the portion of mantle. Now, in the region of mantle and at the region of the Gutenberg discontinuity, let's suppose here this is the Gutenberg discontinuity. Gutenberg discontinuity. Now there is heat which is provided from the region of the outer core. The residual heat keeps on getting supplied from the region of the outer core continuously, isn't it? So as this heat, residual heat gets supplied from here, what it will do? It will immediately melt the portion of mantle. That excess heat will melt that portion of mantle. Now, which is lighter, liquid or solid mantle? Which will be lighter? Apply logic here. Which will be lighter? Liquid, right? So liquid will be lighter. Being lighter means it will try to rise up. So that is where basically it will try to rise up. The molten portions, they will melt the areas immediately above it and they will start rising up. Meanwhile, in this portion, there is some amount of vacancy created. So the cold, just like the convection current, the colder solid mantle, that will replace this. Again, that will also get heated up. So it will melt. Molten portion will melt the area above it. It will tend to rise. More molten portion will tend to rise. More molten portion will tend to rise. All the meanwhile, the solid particles from the surrounding, they will start replacing the risen portion. So that is when it will rise up. And you will have a convection current. You will have a convection current. So mantle is solid. Mind you, mantle is solid. But then you will have the situation where, due to that immense residual heat at the region of the Gutenberg discontinuity, due to that immense amount of heat, this portion will start melting. It will melt the region above it. It will try to rise up. It is liquid. It will try to rise up. More heat, more portions will be melted, more rising up, more portion will be, and in the meanwhile, the solid substances will replace it. Because mantle, as I gave you the analogy yesterday, in case you remember, basically I told you that mantle is like the pulp of coconut. If you have to think about it, that it is solid, but if you press it, it can be compressed, it can be deformed as well, right? So the solid portions will replace it, it will melt, it will rise up. He said this is how heat from the interior gets transmitted outside, outwards. Garima, are you aware about the how many of us are not aware about discontinuities at all? Okay, right. So I would suggest to you, kindly take a look at the recording of yesterday's class. Clearly, you have not attended the class yesterday. Take a look at that. There we have talked about the portion of discontinuities. Discontinuities, they are a zone of differentiation in between different areas. So this talks about transmission of heat from interior to the outside. Okay, transmission of heat from the interior to the outside. So this is your mantle, this is your core, outer core, which is molten. Now this convection current will have two components, vertical component as well as horizontal component. Now he also said that this convection current can come into existence even in the region of asthenosphere. Asthenosphere is also in a semi-molten state, so there also it can come into existence, but we'll study in detail about that because clearly there is no point rushing into it. We will talk about it in detail in the next class. This is where we'll end the session here today. I hope that till now you are comfortable, and just revise this portion before you come for the next class. Then you will be able to cover the portion of the plate tectonics also easily well. Okay, with that, we'll end the session here today. Any kind of question? Okay, let me give you certain areas for map pointing. Good. Certain areas for map pointing. Point it out in the atlas. In case you are not able to find it in the atlas, take the help of Google. So here, first of all, I want you to locate certain mountains. Appalachians, Brooks Range, Rockies, coastal ranges, Andes, Sierra Madre, Oriental and Occidental, Alps, Atlas, Ural, Caucasus, Then Himalayas, all of you know, Karakoram, Great Dividing Range, and locate some of the trenches, oceanic trenches. These will be the dark blue areas in the world map in the oceans. Mariana Trench, the deepest trench. Then Kurile Trench, Peru Chile Trench. If you locate these areas before coming to the class, your understanding of plate tectonics will be much better. Japan Trench, Sunda Trench. Trenches are the deepest portions in the oceans, narrow, deeper portions in the oceans. Okay? Locate these areas, find out the regions around it, and then we meet again in the next session where we continue further. We discover more about this subject. That shall be all from my side, and we meet again. Do take care of yourself. Goodbye. Thank you.